All right, welcome. I'm going to talk about a project called Calabash. As the title says, it's a project for doing automated acceptance testing for mobile apps. It is an open source project. It's free to use. It's open in the sense that you can contribute to it. But if you haven't heard about it before, I'm not too surprised because it's a fairly new project. It's about 6 months since we released it. So even though it's new, it's actually some technology we have been using for quite some more time at the company LessPainful, where I'm at. I'll tell you more about the company later. So the point is that it's something that we've been using for some time to test our clients' apps, so it's not completely immature technology in that sense. But now we decided to change our business model. We decided to open source this technology and to target something which I'll talk about, which is a testing service, a cloud service for doing testing on mobile devices, and also selling support and training on this open source project. So sort of a classical way of making money and supporting an open source project at the same time. So let's get on. So the agenda today is I'm going to talk a few slides, maybe max 10 slides, about automated testing for mobile and some of the challenges that are associated with that. And in particular, I'll give you a list of some properties that I would like to have on the tool that supports automated acceptance testing for mobile. And this list of properties is actually the reason why we created Calabash, because none of the existing tools that are out there would support all these things. So if that list matches your list of properties that you want of a testing tool, then you should definitely check out Calabash. And then I've actually given this talk kind of before, but I've decided to do it differently today. So instead of having about 30, 40 slides describing Calabash, I'm actually going to have maybe 10, 15 slides, and then I'm going to do the rest with live demos. So that's definitely going to go wrong at some point, but that will keep the the mood a bit informal, and I welcome you to ask questions and tell me if you disagree and so on. It'll be, I guess, a bit more live. I am going to focus on iOS because that's my area of expertise. I've been working at Trifork for about 6 years, and the last 2-3 years of my job there was developing native apps for iOS. So that's the reason I came into this business. And at some point I started looking at automated testing for iOS. Anyway, so the point is that even though I'm talking about iOS, most of what I say will apply equally well to Android development as well. So those are the two platforms we support. I'll also show you our cloud testing service by way of example. So first I want to start off with a rant, or sort of my own personal thing I'm ranting currently. So when we do server-side programming, we have a couple of things we do. I just label them professional practices. You can call them all sorts of things. But the things we do to ensure consistent quality and high quality and a short feedback loop. Okay? Like continuous integration, unit testing, functional acceptance testing, all automated. And then we go into mobile, and what happens? Nothing. There we go. Right, it's cowboy land for some reason, right? No rules, we just go in there, hack it out, ship it to the users. It's like all those practices that we used to do, they're gone. No continuous integration, no automated testing, no automated functional testing. Well, at least that was true a year or two ago. I'm seeing that this is changing. How many of the developers in here are doing, let's say, unit testing on their mobile products? That's not everyone. How many are doing continuous builds? About the same. How many are doing automated acceptance or functional testing? Yeah, it's about 3. So for some reason, we've seemed to have dumped those practices, or we're at least not adopting them as fully. Probably that's just because that we're fairly new in the space and we need to learn how to program first and so on. But I really want to encourage that we burn this bastard. And just invest the time once, get those practices going again, do the continuous build and unit testing and acceptance testing. I'm going to talk about automated acceptance testing for this. There are techniques to get all those practices running on mobile as well. So invest the time. All right, rant over. Oh yeah, I just wanted to mention, I was talking to the guys from the eBay Classified group. They have a booth out here, a vendor booth. And they are actually using this technology to do automated regression and functional tests. And they reduced their manual QA from 2 days to about a few hours using automation. So I really want to encourage you just not to listen to me, but also go out and speak to these guys that are adopting it in practice. They have a booth out here. Okay, so what's the QA story like for mobile? Well, as Brian also said, the reality is that we have several devices. You know, they have different screens. They run different resolutions. Okay, so on iOS, you have 3 versions of the iPad. You have several versions of the iPhone, iPod Touches. Even the newest iPhone has a different screen size. You have the Retina versus non-Retina. And you know, Android is just, man. Yeah. So the reality is that if you really want to test everything, then, well, you can't really, right? It's just too many. So what I mean by acceptance testing, I mean the thing that we do to ensure ourselves that the app that we're going to deliver to App Store or a market or whatever channel we're using, it actually does what it's supposed to do. So it's like the final thing we do before sending it off and saying, okay, we're good. So because it's the final thing we do, we want to ensure that it's done in a very realistic environment, because after all, this is the last thing. So we want to test on real phones. You know, emulators and simulators are good, but we're more confident if we've tested on actual hardware that the users are running. Also, these device differences don't appear when you're running, at least not as much when you're running simulators. Also, you know, not only are there many devices, there are also many operating system versions. Several versions of iOS 4 to 6 now, I guess, is what's commonly supported. Numerous versions of Android as well. And they have, you know, different languages you may need to support in your application. You have a condition that's particularly interesting for mobile, which is that the network is changing a lot more often. Like your network capacity is changing a lot more often than if you're doing let's say, a web app for a desktop. The client can be moving between no network and edge, and 3G or 4G or Wi-Fi. And all that impacts on how well your app is functioning. You can run out of storage way more easily than on other platforms and so on. And from my experience, all this testing in most companies, it's a manual process. So the companies I've been working at, we've had release cycles which are maybe a test release every 14 days or 3 weeks. And in principle, you want to ensure that everything is still working, right? You have no regressions when you ship this test version to your manual QA people or your business users. And that is a fair amount of work. And quite frankly, it's very boring, because you're repeating the same test that you did over, but you have to ensure that you haven't crashed the submit screen or whatever. And it's expensive, it takes a lot of time. The example from the eBay guys was 2 days. I don't think that's unreasonable. And we just do see app crashes. Even though something worked the previous release, it's likely, well, it's not likely, but it happens that we break it in the next release. So this costs. Another interesting aspect for mobile is that the visual appearance of the screen, like the representation of graphics and your brand, that's really, really important. Users expect to have a high-quality user experience. So you need to pay additional attention to this. And this is something that's kind of hard to automate. Is the user experience good? Are the graphics looking nice and so on? You can do something, but it's kind of hard to automate. So I think I'm trying to make the case that it needs to be done, but also that it is quite a lot of work in terms of hours to do this automated test. So to do this testing, whether it's automated or not. So you might argue, well, who cares? I can just test on whatever. I have like an iPhone, I have an Android phone, and so on. Why I just test on that, and it's running the same version of Android or whatever. That should be okay. But the truth is that these problems are really significant. So you can have crashes depending on, say, which iOS version you're running, an API that may not be available that you're calling, that could result in a crash. And also you can have sort of graphical errors that depend on screen sizes and resolutions and so on. And it was an interesting example. I think it was Android 2.1. Jonas is sitting here, he can correct me if I'm wrong. But there was an Android library project that Trifork was doing, and they had to implement some security infrastructure code, and had to run on Android 2.1. And they saw that occasionally sort of the login thing would fail. For the Danish people, this is the NemID library, so you know what that is. And it was sort of really weird. And it turned out that on Android 2.1, I think it was, the big integer class wasn't thread safe. So this means that occasionally this crypto computation that was going on would fail and cause random sort of bad login failures. So you can have really nasty differences on different operating system versions and on the different devices. Also, an interesting thing is if you need to support multiple languages, text sizes vary. So if you have 4 languages, in principle, you have 4 times the testing burden, because you need to check that all the text is still visible and look nice. And buttons and so on. So yeah, there is a difference. So here's my list of criteria that I want of a tool to support automated testing, acceptance testing. So first of all, I usually work in organizations where you're working close together with business people. And for that reason, I want to try and minimize the distance between the actual specification of what the app does, which is usually some kind of use case, maybe in a Word document and so on. I want to minimize the distance between that and whatever my test code is doing. Because if there's too big a gap, then I'm not really sure I'm testing the right thing. So particularly if there's zero distance, if the specification is an executable test, well then I'm at least confident that I'm testing the right thing. Also, I want my tests to be fairly expressive in the sense that whatever the user can do, I want to be able to express the same thing, same kind of action inside my test. Also, I want it to be efficient to write, because we all know that writing test code is also something that costs time, and maintaining it costs time. So the more efficient we can have the technology be, then the less time we spend automated testing. Also, we prefer extensibility. That means several things, but particularly what I'm thinking of here is we prefer the open source versus closed source model. For instance, Apple has a technology which is also doing automated acceptance testing, but the problem is that the release cycle for this is so unbelievably slow. So if there's a bug, and there are bugs in a particular version, you have to wait for a major or minor release of that particular thing. So you're just sitting there. You can file a bug on Radar, but I've never had someone answer a bug that I filed. So we prefer open source. Also, this means that you can take the project and build your own version and use that for testing. All right, there are also issues of you don't want to be too low level when you express your tests, because this means that if you're too specific in what you test, then if you change the UI slightly, then all your tests are going to break, and you need to go back to that. So you want to stay fairly high level. So you want to test enough, but not too much, because that will incur too much maintenance cost. Finally, we need to support testing in realistic environments, and what I mean by that is I want to run my tests on actual devices, running different versions of operating systems and supporting different languages, because that gives me more confidence in the app I'm building is actually doing the right thing. And the final thing is I want to support CI. All right, so this gets us to Calabash. So the vision for Calabash is to do cross-platform automated testing, automated acceptance testing, I should say. And the way, the interface you get to Calabash is a technology called Cucumber. How many know Cucumber already? About a third. Okay, so I'll introduce it by example in a minute. It's an extremely simple technology, but it gets us this property of having the description of what the app should do at the same time be an executable specification. When I say cross-platform, and I mean iOS and Android, because that's what cross-platform means in Denmark, or at least in Europe. Of course, there are other players on the market, and we will try to adopt those depending on customer need and depending on how it goes. Right now, we support Android and iOS, and one of the visions is that you should be able to reuse. So if you're building an app, like the same app for different platforms, like you're using PhoneGap or you're using Native to build the same app for Android and iOS, then you should be able to reuse as much as you can of your testing code to try and minimize the overhead again. All right, so Calabash will run on simulators, emulators, and on physical devices. That's one of the project goals. We support native and hybrid apps. So by hybrid, I mean apps that embed web views inside of native apps. We do not support pure web apps. That's not the intention of Calabash. It's free and it's open source, and an important point is that we have a company that's backing the project. So there was a recent study of testing projects, and I don't know if it was restricted to the mobile space, but certainly a study of open source projects. And it turned out that most of them have about a lifespan of 1 year, and then they sort of die, 1 year or less, and then sort of die. But by having a company that's backing the project, hopefully that can give more confidence in sort of the long-term viability of the project, so that larger companies may actually invest in it. And of course, providing support helps with that as well. The final thing I want to talk about is what we call device cloud, or a test execution environment. And that's a paid service that we offer, like an additional add-on service that you can add to Calabash. And what that does is that we are able to execute Calabash tests on real devices, hosted real devices, and the test will run in parallel on these devices, and you get the test results back. And in addition to that, you get some visual test reports so that you can see what your app looks like on different models at the various points. I'll show you an example of what this means, and actually I'll run a test live as well. One important point is that we run on non-jailbroken, non-rooted devices, and we try to be as authentic as possible. Again, to do this, we're aiming at getting as close to what the end user will be running with. And we support CI with like this one-line command. So I just want to show you, so I should say this is a prototype, but I want to show this video because it rocks. This is an early prototype of the testing lab where we run those tests here. So you want to see it in the big screen. It's actually sound, but I haven't plugged it in. You're kidding. At one point we had sound on the phones as well, and there was a client that was testing a very, very strange app which emitted modem-like noises. And there was a point where all the devices simultaneously would emit this noise, and Jonas was sitting in the room, so he decided to turn the volume down. But the point is that we can run these tests on real devices and offer that as a cloud service. Yeah, it looks a bit more organized now. All right, so now I want to try and do demo for the rest of the talk. Time is good. Again, I'm going to focus on iOS, because that's what I know best. I'm going to use a sample application that I helped develop at Trifork, which is for the Danish people. Well, I guess this is international. Well, it's the Roskilde Festival, like this musical festival in the Copenhagen area, where we have, I guess it's close to 100,000 people. So Trifork developed an application for this. I'm not going to talk too much about the app. It's actually kind of interesting in its own. It uses React as its backend. It actually created what is equivalent of a React cluster of about 50,000 nodes, because each phone on the festival was a React node, and it would do peer-to-peer exchange. So the application is interesting in its own right, but I'm just going to focus on testing. Particularly, we're just going to test something fairly simple. There is this menu, the things you can see, like the artists. This is using test data. Some of the images are missing and they may be incomplete, but the point is that you can like go and find whatever your favorite artist, dead skeletons, and you can read a bit about those, and you can listen to some music and you can favorite them and so on. And also we have this map component here. Yeah, you can use my location, where you get like an integrated festival map here, and you can find out where you are. It will actually, if you push, no, that's the wrong button. If you push this button, it will find your current location, and which is apparently somewhere in the US right now, which is because this is the simulator, and on iOS it doesn't, it just uses this location. You can actually set it, but. So that's, I just want to do a simple test, like a live development of a test for the artist list for this. But first I want to talk a bit about Cucumber. So Cucumber is a technology, well, it's a notation, a way of writing tests, and a tool at the same time. So this is actually a Cucumber specification of a feature of your application. It's just a very simple example. And as you can see, this is actually written in pretty much natural language. You have something called a feature, which is like a feature of your app. It's called artists. And you can have a comment here. As a user, I should be able to see all relevant information about artists, like which artists are playing, when, and their country, and so on. That's just a comment. And then each feature consists of a number of scenarios. And a scenario is kind of like a use case. So given I'm on the menu, when I go to the artist list, then I should see the artist list sorted correctly. Okay, so if you're in the domain of this app, you would know exactly what that means. And I guess even if you're not, you still understand what this means. So that's checkable. And here's another scenario. So if I go to the artist list and I scroll to dead skeletons, and I tap the artist dead skeletons, then I should see details, artist details for dead skeletons. So this is something that's human readable. It's readable by non-technical people. Like if you're in a bank, you could phrase this in the language of a bank. But at the same time, this thing is actually an executable specification. So this was the artist. There's also one for map. As a festival attendee, I should be able to get a map of the festival site. It should include points of interest and current location. So here's a scenario. Given I'm on the map, when I tap the My Location button, which was the one I tried to find, then the map should move to my location. That's fairly understandable. Or given I'm on the map and I'm at Orange Scene, which is one of the music stages, when I tap My Location, then the map should move to my location and I should see the orange stage. Okay, so this is understandable, but the cool thing is that it's at the same time executable. So if I run this command, Cucumber, it will execute all the features that I just showed you. The SDK version, he'll just select the iOS SDK version, so 5.1 in this case. Actually, why can't you see that it's saying 5.1? Okay, this is better. So let's try and run this. It will detect where my app is currently at and will start executing. It will wait for the menu. And yeah, that was pretty fast. It went into the artist and then asserted it was there. Now we'll go to artist detail and we'll check that you're at the dead skeletons page. Now it goes into maps. Touch the map button, assert you see those. And it waits a bit because the device has to find location. Now it does the thing where it's at Orange Scene. So you see that it simulates location at orange stage here. And it does an assertion. All right, so this seems kind of magical, right? I've written this plain text, and then I run a tool, and then boom, it's an acceptance test for my, my app. And of course, it's a complete illusion. The way that Cucumber works is that you have each of these scenarios, that those correspond to test cases. And then you have each of these natural language steps. Those are called steps. And the way it works is that for each of the steps, you have to tell Cucumber what does this step mean in terms of executable code. So for each of these, there is what's called a step definition, which is actually, you don't have to understand the details of this yet. I'll just fold it in a bit. What a step definition is, it's a something that associates a regular expression, something that matches text, with a block of code. So the way Cucumber executes is that it takes one step and it'll find a step definition where the regular expression matches that step. Then it'll execute the code, the corresponding block. If there's ambiguity, it will give you a warning. And the rule is that if this block of code completes without throwing an exception, then the step passed. Otherwise, it failed. So a fairly simple model. And now my IDE is going crazy. All right. This is using Ruby because that's the preferred language for expressing tests for Cucumber. There's also a project called Cucumber JVM, which allows you to run, or rather to define steps in other, in JVM languages, like Java or Scala or Clojure. We're supporting Ruby right now, but we will eventually also support JVM-based languages for expressing step definitions. Okay, now let me go into I'm using Emacs for my slide presentation. I love that. Oh yeah, we've executed it. I want to submit this to the cloud, so it'll execute while we are having a coffee and having fun. It'll run on real devices, and then we'll go back later and we'll see the test results. So you can do this. Please don't look at what I'm typing because this is a secret key. This will be online. This is being video recorded, so my secret API key is now totally visible to everyone, and I'll go and delete it after this presentation, so it won't work. The point is, I have a command line tool. I have an app I want to run, an IPA or an APK file, and I have an API key. Actually, I'll use a different one. This is the LessPainful.com website. Here you can create API keys, and what those are is basically they list how you want to run some phones. I want to run a 3GS 511 and a 433 and a 4S. I don't want to run the iPad. I want to run English, and it will generate what's called an API key for me. And this is like the secret I use in my test. So let's go back. Where'd you go? Yeah. I'll use this key instead, and it will upload and check which version of Calabash you are using and what dependencies you have, and it will upload this to cloud execution. It'll take a few seconds. Okay, now you go have coffee, or you listen some more to this. So, how do you get started with Calabash? It's actually fairly simple. We want to have you be able to install and run. You can go to these links. I'll give you this as part of the presentation material. You want to see how Cucumber executes at runtime, and we will see how you can refactor some stuff. So let's go into a fresh version of this Roskilde Festival project. I have one that's not using Calabash already. It's called init. So to do this, in fact, let me just open it so you can see I'm not cheating. Well, Brian went. I was going to tease him with having a faster MacBook than he does. Okay, so I have this project. Well, there's not much to see. I can run it. Hidden simulator. It's the same app. Okay, I'm not going to wait for this. So from here, you can install Calabash by reading the instructions here. Once you do this, you can say Calabash iOS setup. It's slightly different on Android, but it's the same kind of formula. And this will download the current Calabash framework version. I'll explain that a bit more in a minute. And it will actually modify your Xcode project file to generate a new target that you can use for testing. And let's just verify that. Oh, it's so fast. You see here there is now a target. Oh, you don't? Okay. There is a target, -cal, which is a Calabalized, is that a word? It's a version of your app where you're using Calabash. And there's a corresponding scheme you can run. And this gives you actually the same app as you just had, but it also includes some code for automated testing. And I'll explain a bit what that code is in a moment. For now, this is just for doing setup. So the app will run, and I have to watch the video. Users got a bit tired of that. Yeah, you have your artist list and so on. So now we are actually set up to use Calabash. But we do need to have a particular file structure to use this Cucumber tool, and the tool can generate this as well. So I do Calabash iOS gen to generate, and it will ask me, shall I create features? Yes, please. And it's now created a features folder that we can. I don't even know what the feature is, but I'll run it. By running just Cucumber, I'll run on the most current iOS version. Starting up. Ooh, I swipe left, which doesn't do anything. That was just a randomly, or not randomly, it's just a scaffolded feature. So let's remove this, was the one that already worked. Now you see this is my project folder structure, and the thing that was generated was this folder, features, where you put all your Cucumber features and corresponding step definitions. It's generated one that's called my first feature, which is very uninteresting for most apps. So let's write one which is artists. Artist list. And this doesn't make any sense, right? Given I'm on the welcome screen, I swipe left and wait until I see don't swipe left, and I take a picture. So that's not interesting to us. So now we have to start testing, and what I want to test is, if we just start the app. I should disable this. I can just tap this, and I will see 2100 days. Okay, and Calabash actually comes with something which is called predefined steps, which is you can write some text steps, Cucumber steps, without giving a corresponding step definition, because they are actually already, they come with Calabash. So you can actually start writing a test in human language, which is kind of strange. And I have to remember what I want to test here. We've set up. Yeah, okay. So I wanna wait for the video to go away and just to see this artists, and I want to touch it, and then I want to see this this band 2000. Given, I wait for wait to see artists. When I touch this, then I should see 120 days. Okay, let's try and run this. It's actually capital letters. No, let's run it from the command line. So I do Cucumber, and I want to run SDK version equals 5.1. And then we'll restart the app, start executing. So now it's waiting. Touch, and then something failed, which is kind of interesting. It says to me, I should see 120 days, but I didn't find this text. Okay, and the reason that that's happening, if we start the app, oh man. It was even worse as a developer. Right. The reason is there's actually a slash, which is really annoying. Okay, so let's change the... for some reason, it was really important that the bands were written in this particular manner. So let's watch the video again. You'll really hate this by the end of the day. It's nice though. Ah, okay, all tests are green. Good. So you see I've not written a single line of Ruby code, but I actually start testing. So those are called predefined steps with Calabash. Okay, yeah, execution with RubyMine. You can actually integrate this with your IDE, which may or may not be interesting to you. If you're using this RubyMine IDE, you can actually run it from in here, except that it's hidden by the IDE. Boom, which is kind of nice. And as I'll show you in a minute, you can actually set breakpoints and get a debugging experience and so on. All right, so one point about Cucumber is that Cucumber is really about the business. You should express your tests, or rather you should express your specifications in terms of the language of the business. And this isn't really the language of the business. Well, imagine you're in a bank, so business is a bank. This is the Roskilde Festival business. And you know, I guess it's fairly neutral, waiting for something or touching something, but it doesn't have anything particular to do with Roskilde Festival or this app. So let's try and refactor this into like a Cucumber way of doing things. And I want to make sure I use the right wording here, so I'll cheat a bit. Just to make sure I'm not inconsistent with some upcoming stuff. So I decided that the business of this app is not to have two scenarios which are of the same name. So given I'm on the menu, right? When I tap the artist menu item, and I see an overview for the band. Yeah, so that's kind of implicit, but what I'm saying is that when I go to the artist, I should see this band. right? But now I'm not talking in the language of buttons and text and so on. I'm just speaking about, I could speak to this to the like the customer and tell him, well, is this what you want, right? You go to the menu, you tap the menu item, and you should see this. And they go, yeah, that works. But unfortunately, this isn't executable, right? So if I run this, it will complain and tell me that after the video, well, you haven't defined all this stuff. What does all this stuff mean? And it will actually give you a definition how you can do this, right? So you go into this folder called step definitions. There's one called my first steps. This was auto-generated, we don't need it. Okay, and now it tells me, please tell me what it means to be on the menu. And in fact, you can use something which is called macro or step, which is to reuse inside the definition, not as a step, but inside the definition of a step, you can use another step. So you can say macro, I wait to see artists, I think it is, which was just the implementation I had before, but now I'm calling it, so to speak, from another one. I tap the artist menu, well, that's easy. Macro, I touch artists. All right. I see overview for the band. So this is an interesting point. So I said that Cucumber uses regular expressions, but you can actually have capture groups inside those regular expressions. So you can have something in quotes, basically. And that thing is going to be passed as a parameter. Whatever text this is here, it's going to be passed as a parameter to your test script. So this is an artist or a band. So I could replace this thing in quotes with anything. Macro, I should see, then I want to, please excuse my Ruby. This may look a bit strange, but this is just Ruby notation for a string where I can plug in all sorts of stuff, quotes and variables in here. So I want artist, but then remember that I had to put a slash, right? Because there was a slash in the text. But notice that inside my business feature, I'm not using the slash, so it makes it a bit more readable and understandable and hides away the technical details. Run. Yay, okay, we can express in terms of the business. So now you've seen like the most primitive way of using Calabash and how to set it up. And some of my presentation has gone missing. There we go. Now what I wrote here is I just want to have a few slides on the architecture. And I want to check on time because I want to make sure I have time for the fun stuff. I do. So to get you back into presentation mode, just 2 slides here. So in general, the architecture of Calabash is you have your app, of course, native hybrid. And then you have something which is called Calabash clients, and you can have several different clients. So you have one for iOS and one for Android. Those are both written in Ruby. And we have an experimental project which is called Calabash JVM, which should be a shared client for Calabash Android and Calabash iOS, where you write your step definitions in JVM-based languages. But the point is you can have multiple. And the reason you can is because it's a client-server architecture. So you have your app, and then you have a Calabash server. And actually, the clients will talk JSON over HTTP with your server. So this means it's fairly easy to create a new client, because all you have to do is create the client side of this HTTP app. So this server thing is sitting next to your app, and it does things like perform touch events or look into the current views, what text are there, what images, what buttons, and so on. And on iOS and on Android, there are slightly different architectures, but it's basically the same thing that's going on. On Android, you have a special separate app and your unmodified app, and then you do some magic signing stuff to give the special app privilege to perform reflection events on your app. On iOS, you can't do that, so you need to link in a special framework which embeds this HTTP server, but it doesn't change your app. All it does is perform touch events and query into the view of your app. Okay, so but it's the same basic model. And the way it runs is that you have your features, and you have the Cucumber tool that will execute your features, and that produces test results. And then inside your step definitions that are written in Ruby, or maybe Java at some point, then you will use the Calabash clients, either Calabash Android or Calabash iOS or both, if you're trying to do sharing. We expose an API that I'll show you in a moment that you can use to do stuff to your app, basically. See, that's all. I'm really doing light on slides here. So let's do this. Yeah, so we've seen how you can use predefined steps. We've seen how you can use macro steps, but you haven't seen all the fun stuff. It's a shame for this guy. He's missing all the fun stuff. Okay, the underlying APIs. What the power that gives you is that you get to write more robust tests, so tests that are not sensitive to timing issues. You get to write more powerful. There are simply things that are not defined in predefined steps, so you have more powerful APIs. You have faster tests because there are some built-in weights in the predefined steps. And as you'll see, there's sort of an interactive development experience that I'll show you. So that means that developing the tests is more efficient. So let's start with that actually. So using Cucumber to run your test is quite slow, right? So if you're over here in your editor, you're writing your tests, you're writing your specification, you're going into the step definition, and then you write something here, my weird function, blah, blah. And then you run your entire test suite until the point where this exact line of code is executed. And of course, this function doesn't exist, so you made a mistake, you fix it, and then go all over again. This is not a very efficient way of working. So for that reason, we have like an interactive mode where you can interactively talk to your application, basically. So let's show that. The way you run it is you manually start your app. And then let's have the app over here. And then you run, from the command line you run Calabash iOS console. And what for Ruby guys, this is just the IRB that's loaded with the Calabash APIs. For everyone else, it's a magical thing that will make your life better. Okay, so what you can do here is you can experiment with the Calabash APIs. So for instance, let's tap artists. And I will actually interact with their scroll, table view, down, or up. Okay? Or you can, see, I can't remember what this thing is called, but I can inspect it. Okay? So query, button. A lot of buttons. All this information is actually an array of hashes, array of maps. And you can see there are 2 buttons, which are those 2. The way that Calabash iOS works is that we use something which is called accessibility on device, which is really funny. I like to show it. Which means that you can't hear this on, or maybe you can hear it on the video. 2012 Olympics. So the app is intended for disabled users to be able to use apps. So it's available on please shut up. Shh. Good. It's available on all iOS devices that are more recent than 3G, I think. But the cool thing is that it actually gives us a very nice way from our test scripts to identify elements. It's like IDs. There's actually something called accessibility IDs, which is this. But accessibility labels are the thing that it will say when you get focused to a particular item. So we have a function that's called label, which will extract those labels. Give me all the labels. There's one called back to menu and share likes on Facebook. Okay, let's tap back to menu. There we go. Okay. So what you can see is that you can explore the APIs that Calabash iOS provides, like query, like tap, and touch. It's failing because I'm not giving it arguments. And a bunch of other APIs that are available. And this gives you an interactive way. Okay, so let's find an example. Suppose I go to, well, let's remote control it. It's so fun. Go to artists. And I want to check that there is a particular label that has a particular text. But I want to make sure that that label is inside a table view. And you can use this query function, which is a very, very generic query mechanism that will do like arbitrary queries into the current visible view, which is what you usually need in tests. So you can do query table view, and we'll find all UI table view objects in the current view that's visible. Which is completely nonsense because I want the cells, not the actual. There's only one table view, but there are a bunch of cells. Okay, you see a bunch of those. But then the query will support nesting, so you can traverse the hierarchy. So inside, let's say the first table view cell, find me all the labels. Okay, so there are a bunch of labels. I want to filter. No, actually, let's inspect those. So you can give a second parameter, which is a selector that's called on the result. Oops. So inspect those labels and give me that text. So there's this one, which is the one we want, but then there's also the description and the language code. So now I can write query, say, well, let's use this. I can filter based on this. So inside the first table view cell, find me a label that has text 120 days / Okay, right. And now I can express a test in terms of this API, which either fails, throws an exception, or goes good, depending on whether this result is empty or not, right? So you have quite a powerful mechanism here. Another thing you can do is you can change the traverse direction. Usually it goes downwards from the table to the table view cell to the label, but you can also change direction. So you can do label text artists. That's this thing up here. I happen to know in this application there is a custom implementation of the navigation bar. So, but I can't remember its class name. So show me the parent view. So parent changes the search direction to go upwards. Okay, and this is completely unreadable because it gives you all sorts of useful information. And I'm only interested in the class names. So I could do ordinary Ruby programming here. That's an array. I can map an array. Result, give me the class of the result. So I've now discovered, without looking at the source code, I've dynamically discovered that the application uses a navigation bar. All right. Any questions on query? I mean, I know it's a quick intro, but you get the power that you can express in your test cases. You can express fairly detailed requirements on what the UI should look like, or what properties, like the text of a label or the color of a label. Actually, let's try and do color. I think I implemented that. Query, label. If I can remember the correct selector. It's not color. Something else. It was color. Ah, there we go. So it gives me a representation of all the colors, the current colors of the labels. The point is that you have a fair amount of expressive power in this query. Let's move on. All right. Yeah, so let's try and change our test suite. I'm going to deliberately go over time because I promised because of the lunch thing, so I hope that's okay. So this was using predefined steps. Let's change this into using this API. Okay, so I'm on the menu. What I really want to do is I want to not just query for an arbitrary text. I want to query that there is a button which has accessibility label artists. Okay, so it's something like this: query button. And there's a special name you use, which is marked, to denote accessibility labels or accessibility IDs. And in fact, I want to do this interactively. So let's check this. That actually gives a result, whereas this doesn't. But this is just something that returns a result. I want something that throws an exception in case this thing isn't there. And in fact, I don't even want to do this. Let's try and do it. Check element exists. And let's run the test. Boom, failure. The reason is what? Does anyone know? I'm saying this thing should be there. But the point is that there is an animation that's moving. right? And as it finalizes, the menu becomes visible, and only then is the button available. So I need to use waiting. Okay. So there's a function wait for elements exist. And note that this takes an array of elements to wait for. Okay, let's try and run that. And that will wait for a default value of 10 seconds for this thing to appear. And then once it's there, it will discover it and the test will go on. So you need to, when you write your test, you need to usually express those in terms of waiting. Instead of asserting that something is immediately there, you need to say, wait for this thing to appear to obtain a robust test. All right. So I can go and tap the artist menu, touch, button, mark, that's the thing I waited for, artists. Okay. But then there's another thing going on here. If you start the app, when I touch artist, there's actually an animation, and then you see this thing here, this navigation bar with the word artist, which tells me that I'm now on the artist page. So let's write a test for that. So I can wait for, that's the same thing, elements exist. And remember, it takes an array. And then, can you remember from before, if we do the console, that I wanted to have this label here, but it was inside a custom component, right? I did query view sc navigation bar, if I remember correctly. Let's just check. Yeah. So what I really want to express is not just the text should be there, but it should be in the navigation bar. So let's write a query for that. Label text artists. All right, that works. It's tested. We can now paste it in. And this thing I'm doing now is what I mean by having an interactive development experience. You test it out in the console, paste it into your code, and then you're off. Yeah, I'm not going to implement this. Let's just run it. Last thing, just a search that this 120 days band is there. So I've given you a couple examples of the API. There's query, there's touch, there's swipe, there's all sorts of gestures you might need. So let's go into slightly more advanced. Yeah, you've all seen this advanced stuff. So there's a couple of advanced things that Calabash iOS supports that, at least not all of them, I've not seen all of them in other frameworks for doing automated testing. One of them is to perform arbitrary touch gestures on views. So particularly in iPad applications, you sometimes need weird gestures to do whatever the user does, and the testing framework supports this. I'll show you an example. So let's go into interactive mode. And we wait. We can start the console in the meantime. So let's go into this cam events. I haven't shown you this, but it's like the user can create its own cam events. And here you have this date picker thing, which reacts to drag touch events. You can actually interact with it just by saying tap, I think 58 would work. Yeah, but let's ignore that for a moment. So there's something which is called record begin, and that will actually start recording a particular touch gesture that I'm going to perform. So let's just record a gesture where I move this up here. Yeah. Then I say record end, and I can give this a name, move up. And now I can actually use this as a particular action in my test. So I can say playback move up, and I'll perform that sequence of touch events. I was a bit slow, which is kind of cool. But when you do this, you find that you often need to sort of, I want to perform this touch event, but I want to do it slightly differently. So what you can do is you can move the location where you're playing back the touch events by using query, label, text, 02. So now I'm going to move the drag event in a different location. So now it actually touched the 02 and moved that up. And you can do other stuff. You can say interpolate, move up. And now I'm going to take that sequence of touch events I performed, and I'm going to stretch it so that I will actually move 2 cells instead of 1. You can imagine this being useful if you have some kind of drag-drop functionality. You go start, that's a query, label, text, let's say 03. And you can do end, which is the end point I'm stretching it to. Label, text, 01. And now you should see that it's actually moving too, which is kind of cool. I love this thing. So this interpolate, which can, remember I just did an arbitrary recording of a sequence of touch events, and then I changed it. I transformed it using query and using interpolate. So this is a very, very generic mechanism that you should be able to implement most gestures. I haven't seen a gesture I couldn't implement on iOS using this. So if you're using iPad or if you have certain drag drop or whatever, long press, whatever functionality you need, then you can use this mechanism. But it's sort of an advanced API. All right, keyboard. Let's do keyboard entry because I think it's fun. I don't know, camp name. Keyboard enter text. Karl something. I want something longer because it's fun to watch it. That's kind of cool, right? So it's using the software keyboard to enter arbitrary text, and it will actually flip between these keyboard planes to find the characters, which is kind of a nice thing to do. So you can use the keyboard inside your test. Location. It's a feature. It's only supported on iOS 5.0 because it's using an underlying API that's only available there. But you can actually do kind of cool stuff. Set location. Actually, let's go to my location, which is somewhere in the States. Set location. Place is Aarhus. Oh, location disappeared. But we can tap this, and we see we're actually in Aarhus now. And this is the API I used to put my location at the Orange Scene at Roskilde Festival. So you can do this, but only on iOS devices, iOS 5.0 plus devices. Web support, I should say a few words about those. Yeah, Ain, finally. Yeah, it's on Android, yeah.
It's not on iOS 4 and so on.
No, it's because my mind is wired into iOS, so when I say it's only iOS 5.0, it means it's only on iOS, it's only 5.0 and above, and on Android, it's there. And otherwise, you should ask Jonas, he's sitting there, he's doing the Android development. But Android can do location simulation. We're using it for a client. Web, so unfortunately Brian's gone, I'm sad. Because the point is that with web, we can actually test PhoneGap apps and hybrid apps, which are native apps that embed web components. I know you're getting tired, but I want to finish this and deliver my promise on getting you late to lunch. So, where do we have some web content? News. Yeah, so in the implementation, this is actually a content management system that generates this web content here. It's okay that you're leaving. I know time is running. But using the query function, you can actually query into the web view. So this just tells me, yeah, there's a slight technicality here, is that the query function will actually filter things where the center of the component is not visible, which was the case here. So let's query web view. That tells me, okay, there's a web view. But what I really want to do is look into the HTML, the current DOM of the web view. And you can use CSS selectors to do this. CSS colon, give me all the paragraphs. Okay, there are a bunch of paragraphs. Let's just look at the first one so that you can actually read what the result is. And if you focus on this, so it's a map of all the interesting stuff. Here's the HTML, P, class name, body text, help us fill, so I guess that is, yeah, this thing here. Help us fill the audience area, blah, 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 blah. So you can look into this. And you can do arbitrary CSS selectors here. You can use XPath if you want. And the cool thing is, I don't have an example in this app here, but once you've selected something, you can perform touch on it, right? So this means that you can actually drive a web application by finding the corresponding DOM elements and performing touch. Do you believe me, or should I try and find an app where I can Those who don't believe me, come down here afterwards and I'll show you an Excel app where I touch a link. Now everyone believes me because I've just stated that it works. But there's nothing here that's interesting to touch. But using a combination of query to assert into web views, touch to interact with components, and keyboard, you can actually drive a fair amount of web applications using a fairly low-level API, which we plan on extending and making more, more like the Selenium API for web. Okay, I think I'll spare you for advanced query. The point with advanced query is you can perform arbitrary Objective-C selectors on the objects that you find when you do query. Like you can perform methods on a delegate for a table view and so on. But it's fairly advanced stuff. Now, back to the stuff here. If all goes well, this test report has actually been run in the cloud. Yay, it did. So this was the test I initially showed you running on the simulator, which tested artists and map. I've run this on the device cloud, and fortunately everything passed, which is actually slightly cheating, which I'll show you why in a moment. Not because it doesn't work, but because the test was lying a bit. So when you go in here, you will actually see, I've inserted screenshots, various points. You can control it from the test code. So the point is you will see on the, I ran on 3 phones running different versions of iOS, 5.11, 4.33, and 5.01, and different models, the 4S, the 4, and the 3GS. And it will actually generate a visual test report that you can show to your business people or you can use just to discuss and see whether there are graphical errors. And this is working. The simulation stuff actually works on device. That was the first test. I just searched that I can see my location, which is the location of the device, which is secret. Don't look at that. No, it's not secret. It's our office. So this is the one where I simulate location. So actually that was a slightly cheating here. Here the simulation API worked. Here it actually didn't. And that was because that phone was a 4.11. And here it didn't, but that was because I had a slight timing bug where I generate the picture too early, depending on, so there's like a timing issue in the test. So the point is that you can run these tests on real devices. And on iOS, this seems to be working pretty well. We have customers that have crashes, but on Android, you get kind of stuff like this. So we have a test report that's running on a number of different Android, newer and older Android versions, and a number of different models. And this is just a random, like do a screenshot of the first page of an app from Android Market. It used to be Android Market. And you see you have this home screen here, and then you have like this weird graphical thing happening, in this case on a HTC Wildfire on 221. Here the graphics is kind of faded. On LG, more weird graphics. And one of my favorites is over here. Yeah, this one is my favorite. So this is, you have the home logo, and it's weirdly mirrored at the bottom of the screen, and the graphics is faded. And this is on an Xperia. So what this test report does is that it takes your Calabash tests, executes on real, in this case, Android devices, and it generates 2 things. An output for your CI, so JUnit XML that you can integrate in CI, but also something for humans, like a visual representation of your app. And that's what test reports do. Okay, I'll wrap up now. Just telling you a few words on the roadmap. So we want to have more cross-platform in Calabash. For instance, this query function I showed you is not currently supported in Android, but we will be developing that quite soon. And we want to have better support for code reuse across platforms, so that if you have the same app for 2 platforms, you want to minimize your testing code. And we should try and support that as well as we can. There's already a closure-based proof of concept for JVM support. So a closure project which compiles to Java class files, so that you can call those from Java or Scala or whatever you want to do. So you can drive these tests from the JVM. I actually wanted to show it, but now I'm really running out of time. Yeah, and it's open, so we're very interested in hearing your inputs on what's needed and what works for you and what doesn't. You can contribute, you can report bugs, you can ask questions on the free mailing list and so on. Here are the references, and now you have to ask questions for let's say 8 minutes, or just sit here and watch me do closure stuff or something. So any questions? Yeah, question here? Yeah. So there are two stories here. So the question, let me repeat the question, that's the important point. The question is about changing network settings. So simulating that the user has a slow or maybe no internet connection, or at maybe some point later in the test he goes to Wi-Fi, he starts at Wi-Fi and then he goes out the door and Wi-Fi disappears. You know, all the stuff that makes your app break. And that is, it's not out of the box supported in Calabash. You can do some scripting. So on macOS, so for iOS, you can do some scripting of the built-in firewall, which will change the bandwidth that the simulator is using. So you can actually build this into your test on the simulator. So that's one story. On the device cloud, with the hosted service where we run on devices, we have no simulator and we don't do this, but we're building, it's not there yet, but we are building for a customer that needs it, we're building support to, per device, turn up and down the network access, because it's really an important feature. So for a simulator, you have to do a bit of work yourself. I know how to do it. For hosted, we're building it, but it's a good question. More questions? Yeah.
What should be tested with your system? Is it only the UI or the business logic, or I mean, how many kinds of tests do you
Yeah. So Cucumber is about the business, and we're working with Cucumber. So this means that you should focus on the use cases of your application driven from the UI. That's like the golden path for using Calabash. That's what we want to do. With that said, you can still do like functional type tests or integration type tests where you're driving the test from the UI. But always think of it as you're driving the test from the UI, from the user's point of view. You can do like low-level arbitrary invocation of methods in an app delegate on iOS or arbitrary Android method, but that's not the intention. But you can use it to do this. And in fact, the libraries are independent of Cucumber, so you can download the Calabash iOS and Calabash Android library and throw away Cucumber and just use the libraries to do automation in, say, a functional or technical test. But the Cucumber side of it is about the business.
So the backend, how do you set that up?
I would test the backend separately using whatever technology your backend is written in. So if you have a system for, say you have a web backend REST service, I would use a separate system to test that in like a functional integration type test. And then I would also test the same backend implicitly by going through the UI, because at the end, that's what the user is going to see. The question is, I think the question is, you can repeat, correct me if I'm wrong. The question is to get reproducible tests, you want to ensure that, say, your database is in a particular state before you execute the test. Yeah, and the answer is you can do whatever you want. Because once you're into step definitions, you're into Ruby code. That's arbitrary programming. You can start your test script by, before I'm running the test, I'm going to call a HTTP method that will reset the state of the database to a known state. And then I'll run my tests. And then maybe after the test, like a setup teardown kind of thing, you can and yeah, that's a good way of doing it. But you can decide, that's the point. Because it's arbitrary programming. You're not bound to like this text magical thing. You're into Ruby, you can call methods on the internet, like REST services, you can do whatever you want. Does that answer your question? Yeah, good. More questions? Yes?
How about local system on the device, local database?
You mean like the SQL database on a iPhone? Yeah, but I mean, there is no Calabash support for. I did repeat the question. He's waving at me to not repeat the question, I think. So the question is, what about support for device local databases like SQLite database and so on? So in Calabash, you're going through the UI, and usually you don't have a like reset my database button in the UI. At least you could make a special test build where you actually put, and people do this, they make special builds where they put reset buttons. But you can also do the bad stuff, which is using some of the lower level functions to call a custom method on iOS on your app delegate, and then have that do whatever evil stuff on the device you want to do, but only in your test environment. So just only compile that function into your test environment. But yeah, I'm not talking about this, but there are like low-level backdoor functions to do technical things like this, and people use them. Yeah. Another question?
I guess running all the tests takes quite
Okay, so the question is, will the tests take a lot of time to run? And is there a way to limit that time, for instance, to do some kind of analysis where you're running tests that are only relevant to the code I just checked in if you're doing CI? And no, that's not something we support. That would be a sophisticated analysis to try and determine, okay, I'm only on the artist screen and I only want to run tests there. No, you have to set that up manually if you have some kind of... But there are ways to restrict how often you run tests. There are ways to restrict which test you run. You can use something called tags in Cucumber to say, I only want to run the things that are tagged with this particular tag. And you can do various performance optimizations to make the test run faster. The way our customers use us is they usually run, on the device cloud, they usually run one test a day at night, so they don't really care if it takes 5 minutes or 30 minutes, because who cares? You're sleeping. If you're running CI on simulators, then maybe you're a bit more concerned, and you can do some optimizations. Try and eliminate sleeps from your test and so on, and try to use waiting and speed up in general. But yeah, regarding analysis, no support for that. More questions? Let me check time. Yeah, 2 more minutes. We need at least one more question. Yeah.
What's the payment model for device cloud?
It's based on how many apps you're testing. So we have we count an app as a platform. So if you're developing the same app for Android and iOS, that's 2 apps. Otherwise, you'd pay. There is no particular limit on how long your tests run. We will, if some client is using too much time, we'll try, make a reasonable deal with them. But we don't have like a strict limitation on how long time you can run. But you pay per app, and you can run whatever you want. But we say once a day is the common thing because you're running in CI, perhaps nightly. And you have different prices depending on how many apps. You get some discount if you have more apps and so on. You can check out the website for current pricing. No, it's a fairly, the device, so the question is, do you have instructions to set up like your own device cloud? The truth is that's our business. We are pretty good at developing and maintaining and operating this device cloud. And one story is that you don't really want to do that because we know that there is quite a lot of pain. We're trying to do less pain, but there is quite a lot of pain involved in operating and having this run reliably and consistently. So no, there's no instructions for that. You could build it, but it would require quite an amount of research and sweat of operations to have it running stably, which is why we provide it as a service, right? We may at some point open source a internal framework that we have to do device automation on iOS. We already have some device automation on Android that's available, but scaling it to a cloud level is something that we sell. And it takes a lot of work. Yeah, good question. Do you want lunch? All right, thanks. I'm very available for questions and talks afterwards. Otherwise, thanks for listening.